some examples on WebAssign. So question 1, determine if the equation is a linear equation in the variables x, y, z. So check this one. It's not a linear. Why? Because there's power -1. The power -1, that means it's not a linear equation. So it's not a linear equation, at least of x, y has a coefficient other than 1. That's why we're going to choose this one. Go to the second one. Find the linear equations that have the same solution set as the given equations. So for the second one, the linear equation they give you, it's 2x plus y equal 7 minus 5x minus 5. Let's solve this one. I'm going to put the x's on one side and the numbers, keep the numbers by itself on the other side. So I'm going to move 5y, 5y. That means it's going to be 2x plus y plus 5y equals 7. So 2x plus 6y is going to be equals 7. That means this one is exactly like the same one, 2x plus 6y equals 7. That means this is the right choice. Let's go to the next one. Find the solution set of the equations. If your answer depending, use the parameters s and t if necessary. A solution set. We need to find a solution set for this one. So how are we going to find the solution set? We're going to solve one of these, solve the equations for one of the variables. So I have 3x minus 5y equal 0. So I'm going to solve it for the y. That's mean 5, I'm going to move the x to the other side. So 5y, negative 5y is going to be equal to negative 3x. Or move the y to the other side, but I'm going to solve it for the y. Both is going to be right. So 3x equal 5y. Solve it for the y, that means the same thing. This one is 5y equal 3x. So y is going to be 3 over 5x. Now let x equal t. So y is going to be 3 over 5t. So the solution set with x, y is going to be x is t, y is 3 over 5t. That's it for this question. Let's do the same thing with question 4. We have 4x1 plus 7x2 plus 2x3 equals 0. Now I need to find a solution set. So what I'm going to do, I'm going to solve this. It's up to you. Which one you're going to solve it? Let's solve it for the x3. So solve it for x3. That's mean keep x3, move everything to the other side. So here's 2x3 is going to be equal to negative 4x1 minus 7x2. Then divide by 2. So x3 is going to be negative 4x1 divided by 2 minus 7x2 divided by 2. That's mean x3 is going to be negative 2x1 minus 7 over 2 x2. So now here's x3. Let x1 equal, they ask you to use S and T as necessary. So I'm going to use X1 as a S, and X2 is going to be T. That means the solution set is going to be X1, X2, and X3, which is equal X1 is S, X2 T, and X3 is going to be -2, X1 is S, minus 7/2, X2 is going to be T. So here is the solution set for this example. You have to plug in S here with X1 and T here with X2. Question 5, solve a system by back substitution. So we have 4u minus 3d equal 1 and 2v equal 18. 2v equal 18. So we need to solve by back substitution. Now we're going to solve this one. We're going to solve this one. This is the second one, and this is the first one. So from the second one, I'm going to say 2b equal 18. That means divide both sides by 2, so b is going to be equal 9. Then we're going to want to substitute b on the first one. So 4u minus 3b is going to be equal 1. 4u minus 3 times b, which is 9, equal 1. So 4u is going to be minus 27, is going to be 1. Move 27 to the other side. So it's going to be 4u is going to be 27 plus 1. This means 4u is going to be 20. And u is going to be 7. Both sides by 4, u is going to be 7. This means the solution set u is 7 and v is going to be 9. So for this example, so we just have to write down here. Be careful, you don't have to put parentheses or bracket because there's already a bracket here. So it's going to be 7, 9. That's it for this example. For number 4, the same thing, and you're gonna enter your solution, I think, with comma. So you have to enter your solution with comma. Solution like x1, comma, x2, comma, x3, comma. For example 6, we're gonna do exactly the same thing, but now we have system with 3 linear equations. And we need to find x, y, z. So we're going to do exactly the same thing. X minus y plus z equals 0. And 2y minus z equal 1. And 5z equal -1. So here is the system with 3 linear equations. This is the first one, this is the second one, and here's the third one. So now I'm going to solve the number 3 because this is the easiest one. So 5z equal -1. That means I'm going to divide both sides by -1. So z is going to be equal -1/5. Now I'm going to substitute this one with the second one. So I'm going to say 2y minus z is -1/5 equal 1. So it's going to be 2y plus 1/5 equal 1. Then I'm going to move this one to the other side. So it's going to be 2y equal -1/5 minus +1. Then I'm going to find the common denominator. So 1/5 plus 5/5, then it's going to be 2y equal 4/5. Divide both sides by 2. So y is going to be equal 4 over 5 divided by 2. And this one is going to be 4 over 5 times 1 over 2. So y is going to be equal 2 over 5. To simplify this one, it will be 2 over 5. Now I have y, I have z. I'm going to plug in y and z in the first one. Z, plug in the first one to get the value of x. So x minus y is 2 over 5 plus z, which is negative 1 over 5 equals 0. Then x minus 2 over 5 minus 1 over 5 is going to be 0. Combine these together because they have the same denominator. So it will be x minus 3 over 5 is going to be equal to 0. Then move it to the other side, that means x is going to be equal to 3 over 5. So the solution set for this system is going to be x, which is 3 over 5, y is 2 over 5, and z is negative 1 over 5. This is the solution set for this example. We can type it here. There is the division, which is 3 over 5 for the x, 3 over 5, comma. The second one is 2 over 5, so 2 over 5. And the third one is negative 1 over 5. Going to be negative 1 over 5. That's it for this example. See, the next example, we're going to do exactly the same thing, but the difference between this one, this is back substitution method. This is lower triangle system, so it's going to be by forward substitution. Because we have the x, you're going to plug in the x in the second one, and then you're going to plug in xy with the third one to get the value of x, y, z. Let's try this one. So the system is going to be, this is question 7. The system is x equal 4. Careful when you write down the system. You see, I put the space here for the y and z. So in case when I'm using the matrices, I'm not going to forget the y here is 0 and the z also 0. So here is 2x plus y equal plus y equal negative 3. The last one is negative 3x minus 5y plus z is going to be equal 18. So here's the system. We can do exactly the same thing. I have the value of x, so x equals 4. That's me. I'm going to plug in the value of x with the second one. Then the first equations, and then the second one, and here is the third one. Plug in x on the first one and the second one. So 2 times 4 plus y is going to be negative 3. That's mean 8 plus y is going to be equal negative 3. Move this one to the other side. So y is going to be equal negative 11. Here's the value of y. I already have x. Plug in x and y with the third one. So it's going to be negative 3 times x, which is 4. Minus 5. Y is negative 11. Plus z is going to be equal 18. Simplify this one, so it's going to be negative 12 plus 55 plus z is going to be equal 18. Move these two to the other side. That means z is going to be equal 18 plus 12 minus 55. But I need to find the value of z. So in this case, z is going to be equal to negative 25, because 30 minus 55 is going to be, that means the solution set x is 4, y is negative 11, and z negative 25. This is the solution set for this system. Let's check example 8. Example 8, find the augmented matrix of the linear system. Be careful if you look to this system, you have always to make sure before you write down the augmented matrix, all x's here, x2, x1, x2, and x3 on the same column. And if you have extra number here, just by itself, like for example here, if you have plus 5, you have to move the 5 to the other side. You see, the constant is going to be on the other side. So to write down the augmented matrix for this one, I have 2, we're going to write down the coefficients. 2, 1, and here is negative 1. For the second column, 2, and you see on the second equations, there is no x2, that means it's 0. They're going to leave it empty. For the x3, it's going to be, for the x2 with the third equations, it's going to be 3. And here's the third column, here's going to be negative 1. Be careful, it's minus x3. And here's going to be positive 1. So here's 1, and here's negative 3. Now, on the other side, constant number 4, and this one is going to be 0, and the last one also is going to be 0. That's it for this question. We'll go to the next one. So next question, find a system of linear equations have the given matrix. We have the matrix and we need to find the linear system. So that's why I'm telling you, be careful, because we have now the opposite thing. So question 9, we have the system. The system is 0, 1, 1, and here is the constant 1. The second one is 1, negative 1, 0, 1. And the third one is 2, negative 1, 1, and 1. So here is the system. That means here is x1, this is x2, and here is x3, and this is the constant b. That means x1 with the first equation is 0. So there is no x1. With the first equation starts with x2. So 1x2 plus x3 is going to be equal 1. The second one, there is x1 with the second one, so it's going to be x1 minus x2. There is no x3, so equal 1. The third equation is going to be 2x1 minus x2 plus x3 is going to be equal to 1. That means here is the system for this augmented matrix. So which one? You see this option, there is no x1 here, or x, y, z, it depends about which variable you're going to use. So the same thing, now here is x, y, z, and here's the missing one is the z, which is x3, the same thing. Here is the last one. Number 10 is solve this one, solve the linear system. So here is the system. Now we need to find the solution of the system by using the matrices. So the first thing, I'm going to write down the augmented matrix for the system. -2, 3, -1. Here is the constant b. Second step, here is 1. There is no x2, but x3 is 1. The third step is -1, 2, and -2. Here's constant b, and here's constant b. So here's the first step. We're just going to write down the augmented matrix. So let's keep going. So my goal is to make the diagonal equal 1, and everything lower the diagonal and upper the diagonal equals 0. So here's the how we're gonna use the matrices. The first thing what I'm going to do, I'm going to say divide the first row by -1. Here is the new row. I'm going to say the old one divide by -2. So the result here is going to be -2 divided by 2 is going to be 1. Here is going to be -3/2. And here is going to be 1/2. And the next side is going to be 1/2, -1/2, -1/2. So this is the first step. Next step, what I'm going to do, I'm going to write down everything exactly the same. So you can know this is only the first step. You can do it right away by changing these two numbers to zeros. -1, 2, -2, 0. But I'm going to do it step by step. Now I'm going to write down this again and do the next step. 1, -3/2, 1/2. And here is -1/2. And here is 1, 0, 1, -1, 2, and -2. There's 2 zeros. The step from here, I need to change this one to 0. So what I'm going to do, I'm going to say new R2, I'm going to multiply -1 times R1 plus R2. And to change this row, I'm going to say R3, I'm going to multiply, just add R1, because I'm going to multiply R1 by 1 and add it to R3. It was my goal to make these 2 zeros. So let's check that. And we have to do the whole change for the whole rows. So the first one, here is the first row exactly the same. There is no change on it. And 3/2, and here is 1/2, and here is -1/2. So the change is going to be on R2 and R1, R2 and the 3. So -1 times this 1 plus 1 is going to be 0. -1 times -3/2 is going to be 3/2 plus 0, so it's going to be 3/2. -1 times -1/2 is going to be -1/2. Their number is going to be -1 times 1/2 is going to be -1/2. Add to 1, this one is going to be 2 times 2/2, so it's going to be 1/2. This means this one is going to be 1/2. -1 times -1/2 is going to be 1/2 plus 0, so it's going to be 1/2. So we're done from the second row. From the third one, we're just going to add these 2 rows. So this one is going to be 0. We're going to add -3/2, -3/2. You're going to add with 2. So we need to get the same denominator. That's mean going to be -3/2 plus 4/2, because you're going to multiply this one by 2 and multiply this one by 2. So it's going to be 1/2. This mean here is going to be 1/2. 1/2 minus 2. 1/2 minus 2. Minus 2 is 2/1. So you're going to multiply this one by 2, multiply this one by 2. So it's going to be half minus 4/2. And it's going to be -3/2. So here is going to be -3/2. And the last one, -1/2, add to the 0, so it's going to be -1/2. So we're done on the first row. Here is our new matrices. Let's keep going. I'm going to write down this one here, and I'm going to keep going. Same process. Now, next step, what we're going to do, we're going to convert this one, because here's our goal. I told you before, we need to convert all the diagonals to 1. So each step, when we're done, this is the first step. Now the next step, this is 1. All the numbers here is zeros. Now next step, I need to convert this number to 1. So it's up to you if you want to divide by the same number, if you multiply by the reciprocal because it's a fraction. So it's going to be the same. That means we need to get R2 is going to be the old one divided by 3/2. That means the first row is going to be the same, negative 3/2. And here is 1/2, negative 1/2. And the last row is going to be the same, 1/2 and negative 3/2. And here is going to be negative 1/2. The second row, this one is 0. This one is going to be 1. Now, 1/2 divided by 3/2. So 1/2 divided by 3/2. Cancel these. So it's going to be 1/3. That means the number here is going to be 1/3. And 1/2 divided by 1/2 divided by 3/2, which is the same thing here. It's going to be the same result. So it's going to be 1/3. Done. Now, next step, I'm going to convert this number to a 0, because that's our goal, convert everything here to 0. So we're going to get back substitution method. So I need to convert this one to 0. That's mean R3 is going to be negative 1/2 times R2 plus R3. So here is the first row, negative 3/2, 1/2, negative 1/2. And here is the second one. Didn't do anything with the second one. And the third one here is 0. So this number is going to be 0. Now, negative half times R2. Negative half times 1/2, 1/3. This is going to be negative 1/6. And we're going to add 3/2. So I need to find the common denominator. So this is minus, multiply this one by 3, so it's going to be 9/6. And then it's going to be negative 10/6. Can you simplify it? Yes. So it's going to be negative 5/3. So here is going to be negative 5/3. 5/3. The same thing with the last one. Negative 1/2 times 1/3 is going to be negative 1/6. So here is going to be negative 1/6, and you can add negative 1/2. So now we're going to multiply by 3, multiply by 3. So it's going to be negative 1/6 minus 3/6. And then it's going to be negative 4/6. And then it's going to be negative 2/3. That's the last number here. It's going to be negative 2/3. Now we're done. This is just one more step. You need to convert this one to 1. It's fine, and keep going to convert all these numbers to zeros. We're going to do the same steps next class. But now we have to use the back substitution. So let's start. This is x3. That's mean negative 5/3. x3 of x here, x3 is going to be equal negative 2/3. That means x3 is going to be equal negative 2/3 divided by negative 5/3. Cancel the 3, and the result is going to be 2/5. So this is x3. Plug in x3 and the second one. The second one, it says x2 plus 1/3. x3 is going to be equal 1/3. That means x2 plus 1 over 3 times 2 over 5 equal 1 over 3. So x2 plus 2 over 15 because cross multiplication equal 1 over 3. Now that means x2 is going to be 2 over 15 minus 2 over 15 plus 1 over 3, which is equal, x2 is going to be equal negative 2 over 15 plus 5 over 15. And then x2 is going to be equal 3 over 15. And that means x2 is going to be equal 1 over 5. So here is x2, 1 over 5. We're going to plug in x2 and x3 in the first equations to get x1. We're going to do the same steps. We're going to keep going. The first equations is x1 minus 3 over 2 x2 plus 1 over 2 x3 is equal negative 1 over 2. Then x1 minus 3 over 2 x2, which is 1 over 5, plus 1 over 2 x3, which is 2 over 5, equal negative 1 over 2. That means x1 minus 3 over 10 plus 1 over 5 equal negative 1 over 2. Let's add these together. x1, I'm going to multiply this one by 2 and this one by 2, so it's going to be 10 minus, going to be plus 7 over 10 equal negative 1 over 2. That means x1 is going to be negative 7 over 10 minus 1 over 2. x1 is going to be negative 7 over 10 minus 5 over 10. And then x1 is going to be equal negative 12 over 10. That means x1 is going to be, I2 is going to be 6 over 5. Negative 6 over 5. So this is x1. That's it for this example. It's a longer process, but you have to be accurate and keep in your mind always. You have to be careful when you do the addition and multiplication between the fraction. And you have to practice on this example because it's going to be the same thing when we start next section on chapter 3. Here's the mistakes here. So let's check this one again because 1 times 2 is going to be 2 over 10. That's mean here's 2 over 10. So when we add these together, it's going to be negative 1 over 10. Equal negative 1 over 2. So we're going to convert this one to the other side. It's going to be 1 over 10 minus 1 over 2. Then multiply this one by 5. So it's going to be 5 over 10. And this one is keep it 1. Then 1 minus 5 is going to be 4, negative 4 over 10. And then simplify this one by 2 is going to be negative 2 over 5. So x1 is going to be negative 2 over 5, x2 is going to be 1 over 5, and x3 is going to be 2 over 5. That's why you have to be careful when you're working with the fractions. Do not convert to decimals, because that's what they're going to accept it. Even if you check here, this one is going to be -2/5. Let's check that. And here is the right solution for this example.